Alright guys, we are on the last section, chapter 4. This is actually a pretty quick lesson. I guess I'll see how long it ends up taking, but it should be pretty quick. So let's go ahead and go through the warm-up here. Again, please try it yourself first, especially like the true or false questions. I want you to really think about it, and then come up with your answers and play the video back and see how you did. Okay, so what we're going to do here, we are going to be... well, let me get my pen up. I didn't have it up yet. Okay. So number one, we're going to be finding each angle measure. So this is something, again, we've kind of talked about in class a little bit. And again, a lot of the concepts, not a lot, but some of the concepts I've really mentioned in class already. So that's why I'm saying hopefully this lesson goes fairly quickly. But this is an equilateral triangle. Now, earlier we learned about equilateral triangles and like naming triangles, things like that. The thing that I mentioned is that you have an equilateral triangle. That's not the same, but it's, you know, if you name a triangle by its sides, it's equilateral, but if you name that same triangle by its angles, it's going to be equiangular. And when it says find each angle measurement, you see this is equilateral, so we know it's equiangular. Now, I'd rather you not, I mean, you want to know it's equiangular, but I'd rather you not say, oh, these angles are congruent. What I want you to do is say what they actually are. If you don't know what they are, here's how you figure it out pretty quick. The three angles add up to 180. So if they're all the same, if you divide by 3, you should get each individual angle. So that's going to be 60 degrees. So these angles are all 60. Concept you're going to need to know in this unit. Okay, so number 1, those angles are 60. Now number 2 and 3, true or false? And if it's false, explain. Every equilateral triangle is isosceles. Now, some things you want to know, if you don't already. If you have an isosceles triangle, that's going to be a triangle with 2 congruent sides. So you need to have 2 congruent sides. Now, if you have an equilateral triangle, you have 3 congruent sides. Now again, isosceles you need to have at least 2. So it's a very similar concept actually to something like a rectangle and a square. Maybe you don't know this already, but you will because we have a chapter on quadrilaterals. But a square here, I'm gonna try to draw one if I can, is actually a rectangle because to be a rectangle you have to have 4 right angles, which a square has. And you have to have opposite sides congruent, which a square has. Those sides are congruent and those sides are congruent. Now they happen to all be the same, but they have the properties of a rectangle. So same thing happens here. We have equilateral triangles. Well, they have 2 congruent sides, so they are a special isosceles triangle. So this would be true because again you have at least 2 pairs of congruent sides. I can have those 2, or the bottom and right and bottom left, whatever. So that would be true. Now number 3, every isosceles triangle is equilateral. Well, that's going to be false. Again, you can just kind of come up with a counterexample in this case. So I can just kind of set up a situation where I have 2 congruent sides. Bam, bam. And this one would be a different size. So that would not be equilateral. All the sides are not equal. So 3 would be false, and just give a counterexample and you'd be good. Remember, counterexamples can be statements, they can be pictures. This is a picture, so I just drew it. All right. Okay, so let's kind of jump into this chapter. Now you see it's on isosceles and equilateral triangles. That's kind of what our warm-up's all about as well. So what we're going to be learning about today, students, you guys, are going to be able to prove theorems about isosceles and equilateral triangles. You're also going to be able to apply properties of the isosceles equilateral triangles because there's more to, especially isosceles triangles, than just they have 2 congruent sides. Okay, you kind of know the concepts with equilateral because we've kind of been mentioning it. So hopefully you know those. There's actually more concepts you're going to need to know about, and they're not all going to be covered in this lesson, but I can probably mention them to you. Okay, so first thing, let's talk about the isosceles triangles. A couple things you want to know about isosceles. 1, they obviously have 2 congruent sides. Now, just so you know, this is by the definition. Don't mind my computer beeping at me. This is by definition of isosceles triangles. So if you asked what is an isosceles triangle, it's a triangle with two congruent sides. But we also have two congruent angles. So this would be the isosceles. Did I just do that wrong? Yeah. Isosceles triangle theorem. And this is, again, the extra information that we'll have here. So we know that two sides and two angles are congruent. Now these angles, 2 and 1 in this case, are called base angles. Now this triangle is drawn in this orientation on purpose. Because a lot of times people think of base and they think of bottom, but it's not necessarily the bottom. The base angles are the angles that are across from your congruent sides. If the sides are the same length, then the angles that make those sides are also going to be the same length within the triangle. So we want to know all those different concepts. So we'll be filling them in piece by piece as we go through, but I would kind of make sure we make a note and write those down. Alright, so we have some theorems here. We got your isosceles triangle theorem. So you want to, again, if you haven't done so already, this is our last lesson in this chapter. There's been a lot of theorems, in this chapter. We're doing lots of proving, lots of postulates as well. So if you haven't been writing those down, well, shame on you. You should be writing those down. There's going to be a grade associated with it, and it really helps if you have those theorems in front of you along with your reason sheet when you're doing your proofs, which, as you know, there's a lot of them in this chapter. So make sure you're keeping track of these, not just putting them in your notes, but writing them down on your theorem sheet. So anyway, we've got your isosceles triangle theorem. Says if you have a triangle with two congruent sides, then the angles are congruent. Or if you say you have, isosceles triangle, right? The converse, though, and again, by the way, I said angles, so that's not labeled on the figure, so I'll go ahead and do that. So I'm going to label these angles congruent. The converse goes the opposite way, and the converse isosceles triangle theorem says if two angles are congruent, then conversely, right, you should know that the sides are congruent. Understand converse just flips the theorem around. Make sure you kind of write those down and understand them. There's just another name for it. You don't need to name it that. I always call the isosceles triangle theorem. Base angles of an isosceles triangle congruent. Sometimes what people call it. You can just call it what it is. Okay, now there was a example I am skipping because the example was actually a bad example. I went ahead and looked ahead because this book tends to have some bad examples. If you don't care, you can just skip over it. But they're telling you like a star was like a certain distance, and they wanted you to set up, and then they said like 6 months later, you want to do the distance from the planet to the star, and you're like, okay, this is how they wanted you to set it up. And then they said 6 months later, you'd have an equidistant. But the problem is, that's what they wanted you to set up. They didn't really specify where that star was, so the star could have been over here, and then it would be a bad problem, because they didn't tell you where the star was. So I'd be like, huh? So I skipped that example. So if you see us starting with example 2, that's why, because we had an example that did that, and it was kind of weird. So anyway, and that was dealing with the definition of isosceles triangles. Now we're just jumping into the angles now of isosceles triangles. So example 2a, it says find the measure of angle h. Now these are the ones that students tend to mess up sometimes. I deal with this a lot in SAT as well, so this shows up on SAT. But anyway, we're trying to find angle h. Now here's what you need to know, is that if this is an isosceles triangle, then we should know that these angles are congruent. So what you could do on something like this is call them x degrees or y degrees, give them a variable name, because that's how you're going to kind of set this one up. So if you are trying to find the measure of the angle, you need to set up the equation. I'll actually put it down here. 2x plus 48 equals 180. Again, if you look at these three these three angles add up to 180 by the triangle angle sum theorem. And we know by the isosceles triangle theorem that these base angles are congruent. So you can set up this equation and just solve for x. So subtract 48 from both sides. So I get 2x equals 132, and then divide by 2. So x equals, and if you don't know how to do it, again, 2 goes into 13 6 times. That's going to be 12. Subtract, pull down the 2. 2 goes into 12 6 times, and we get 66 degrees for x. Now again, make sure you understand x is the measure of angle h. You should finish your question off saying that the measure of angle h is 66 degrees. Again, understand they told you it's an isosceles triangle, therefore the angles, the base angles, are congruent. Remember, when I say base angles, I mean the angles across from the congruent sides. Okay? So, similar situation here. We have to say we'll find the measure of angle n. Now in this case, you'll see that they're giving you different expressions for each angle, but isosceles triangle, these are your base angles, not because they're on the bottom, but because they are across from your congruent sides. So we can set these angles equal. 6y equals 8y minus 16. So if I'm solving this, I can subtract 8y from both sides. So I get negative 2y equals negative 16. Because these are being multiplied, I can then divide both sides by negative 2, and y is going to equal 8. Now they want the measure of angle n. Again, remember why I set this up. These were the base angles. Isosceles triangle theorem says that these base angles are congruent in an isosceles triangle. So I set those angles equal, and I solve for y. Now I need to find the measure of angle n. Well, that is going to be 6 times 8, so 48 degrees. So two different scenarios you can see where you have to understand the that the base angles of an isosceles triangle are congruent. Either you create your own variables or they give them to you. Alright, next up, going to talk about those equilateral triangles. So this is again a corollary theorem, which means it's based off another theorem. This one, it says if a triangle is equilateral, then it is equiangular. Again, we've already kind of talked about it because it makes perfect sense, right? So hopefully it's easy to understand. But if equilateral, we have all the same sides. You can kind of say, well then, if you have all the same sides, that means your angles should probably be the same angle as well, because they form the same length side. They open up to the same length side. And again, remember, in addition to that, just know that these are 60, 60, and 60. You'll use that a lot more than you think right now. This gets thrown around quite a bit, especially in trig. So make sure you understand those, and we'll use it a lot this year. This is a very, very common concept we're going to need to know. And that's our equilateral triangle corollary theorem. Another corollary that we have, same basic premise, right? If it's equiangular, then it's equilateral. If you know a triangle is equilateral and it's equiangular, then you should be able to say the opposite, and it would be true as well, obviously. Again, these are things we've kind of already talked about, so I'll kind of move right along. Okay, so knowing that, they say find the value of JL. This is pretty straightforward. They're telling you have an equiangular triangle. You know then it's equilateral. So you know all those sides are the same length. So in this case, all we need to do is set up our equation. 2t plus 1 equals 4t minus 8. So to solve, I'm going to go ahead and add 8 to both sides. I'm trying to get the variables on one side and the numbers on the other. So that's going to give me 2t plus 8 equals 4t. Now let's get the variables on the other side of the equation by subtracting 2t from both sides. Therefore, 8 equals 2t. Lastly, I'm going to get rid of the 2 by dividing both sides by 2, and t is equal to 4. Now that is not the question, or not the answer to the question. They said find JL. Please answer the question. Especially if you're doing a quiz, you do all this and you get half credit because you didn't follow directions. Follow the dang directions. I want JL. So if I'm going to find JL, I'm going to go 2 times 4 plus 1. So that's going to give me 8 plus 1. Therefore, the side lengths, including JL, are all equal to 9. And it'd just be 9 units if you want to put a U there, because we don't, it's some like inches, feet, I don't know what it is. So you say units of measure, 9 units, whatever it is, and it would be good. Okay? Again, just using your corollary theorems. And that lastly, we're going to talk about our proofs. This is just a reminder about coordinate proofs, using the XY axes as a side length, especially if you have a right angle, starting at the origin, things like that. We already talked about in the last lesson, so I'll kind of skim over it. And finally, this is our last example. The coordinates of isosceles triangle ABC are at the following points. So if they're giving you some points here, I'm going to go ahead and label them. Looks like I have a negative and a positive value. So I'm going to make sure when I draw my XY axis, I give myself some space on both sides. Looks like my Y values, though, are going to be positive. So I'm going to go 1, 2, 1, 2. And I'll go up 1, 2 as well. And here we go. They're telling me the coordinates of isosceles triangle ABC are A at 0, 2B. Now, I don't know. Let me actually, yeah, that's fine. I do want to show you something here. All we really know at this point is that we're going up to B, and I don't know what B is. That's kind of an issue, because B doesn't have to be the same measurement as A. So I'm going to use a different scale on my y-axis just so you can kind of understand that fact. I mean, they may be the same measurement, but more than likely they're not. So I'm going to label this 0, 2B, because the scaling may be different. B may be like, if B was like 4, then 2B would be 8. Now if A was equal to, 1, then 2A would just equal 2. And you'll see like those values aren't the same. So it's important to understand that you understand that concept, so you don't want to use the same scaling if you want to try to be accurate as you can. So I have that, and then I have negative 2a here, so negative 2a 0, and over here I have 2a comma 0, and x is the midpoint of AB. So it looks like A was 0, 2b, so that's A, and B is a negative 2a, so that's B, so therefore that's C. So here I go. I got these points. I'm going to go ahead and connect those points real quick as best I can. Okay. Alright, so they're saying again, x is the midpoint of AB. So x, I got AB right here. I'm going to change my color. I don't know where that is exactly, but I'll put x here. That would be x. I'll figure it out. And y is the midpoint of AC. So AB, AC over here. So I'll go y. Again, I'll figure that point out as I go. So we're going to then prove that triangle XYZ is isosceles. So to prove that it's isosceles, I want to show those sides are congruent. So what I'm going to do here, and they said prove that triangle XYZ. So I need to find this triangle right here, XY, and before I even get to that, sorry, they're talking about this point, Z, and Z, we don't know where it is. The point is, and again, if you read it, it says the coordinates of this triangle ABC are A, B, and C. So you see ABC. You see X is a midpoint of AB, so you don't see a Z there. You see Y is a midpoint of AC. You don't really see that there. The one thing you may want to include here or understand is, Z is going to have to be what they should say, and let's just kind of put that in there. Otherwise, this is similar to that planet problem where we can have a big issue if like Z is over here. Actually, I can put Z here. That would be a big issue. If Z was like horizontal here, I wouldn't have a triangle. So I'm going to kind of give it a specific point. So I can say that Z, so given Z is on, I'll just use this as an example to help us prove this, on the y-axis. Again, otherwise I can come up with a counterexample. I would put Z right here, or put Z like right next to Y or something like that, and it wouldn't be true. So we need to have Z in the middle. If it's in the middle, then we can prove this. So I can say z is on the y-axis, doesn't matter where. We can use, just a point here if we wanted. I'll call that z. And I'll just use that point 0. I'll call it 0, 0c. Okay. If you're going to use, the coordinate proofs here, first thing we're going to need to do is find the midpoints. Let's find these values. So in this case, I would go ahead and find the midpoint. So the midpoints are as follows. So for x, that's going to be the average of your x's and your y's for a, b. So I'm going to go 0 plus negative 2a over 2. And then I'll go 2b plus 0 over 2. I'm adding the x's and the y's. So x equals, looks like negative 2a over 2, so negative a. And this is 2b over 2. The 2's cancel, and I get b. So I get negative ab. Also do the point y. Y equals, add your x's. So I'll go 0 plus 2a over 2. And then I'll go 2b plus 0 over 2. Same thing here. Looks like you just get zeros gone. So 2a over 2 is a. The 2's cancel. 2b over 2 is b. So I got my points. I have a and b. Okay, so moving on here, I want to then find these distances. I'm going to just, again, it doesn't matter where the point is, I'm just using this as a visual. So I'm going to find these distances by doing Pythagorean theorem. Again, your answers are going to be in terms of variables, and that's fine. But what you need to do then, if you're going to set up these triangles, is recognize that your lengths are going to be in terms of variables, and you're going to find them by subtracting. And again, I can use this either way. I'll go here. I'm going to go from C to B, or from B down to C. So this distance is B minus C. This distance here, it looks like I'm going from negative A to 0, so the distance itself is A. So these values are that. Now if I came over here and did the same thing, you would notice I'm going from 0 to A again, and this vertical distance I'm going from C to B. So if you want to find that distance from C to B or B to C, you would subtract those two values. Like if I was going from 2 to 5, the distance would be 3 because I'm subtracting those two numbers. So the next thing I would then do, get that color again, I would find, I have to prove or show xz. I have to find xz. I'm going to do that by doing the Pythagorean theorem. I go a squared plus b minus c squared equals, just call it d squared because of the distance, because I already have a c in my problem. So a squared plus b squared equals d squared. It's a distance. So that's going to be a squared. And if you don't remember how to do this step, well, this is that one little step, and it's not the only time we'll do it, by the way, where we need a FOIL. I want to go b minus c times b minus c. If you find yourself having to do that, then you just have to suck it up and do it. And by the way, it's one of these things, we're in geometry, but there's a lot of algebra we've learned, and we need to we need to remember it, because your next class after this year is Algebra 2. And if you think that you're not going to FOIL after that, after Algebra 1, you're sadly mistaken, and it's going to be like everywhere. So don't blow this off. FOIL the dang thing and deal with it, and stop your whining. But anyway, we're going to FOIL this out, and that means first I'm going to distribute. It's really distributive property, by the way, guys. I'm going to distribute my b first outside, and then inside last. So first would be b squared. Outside would be minus bc. Inside would be minus bc. And last would be plus c squared. And that equals d squared. So this simplifies out to d squared equals, looks like I have a squared plus b squared plus c squared minus 2bc. And d is the square root of all that. No, you don't have to simplify that because you can't. So, I mean, all those terms have to be a perfect square, and they're not. So I'm kind of stuck here. I don't have one big old perfect square, like all this squared. I can't do that. So that's your distance. Now you're going to do that here with YZ as well. Once you've done that, you've shown that these are isosceles triangles. So the work should all be the same if you set it up. So if I just went, a squared plus b minus c squared equals d squared, because it's the same setup, I can just jump down and say it equals that. So I can say that they're both equal. So therefore, xz equals yz. Therefore, triangle xyz is isosceles. So like I said, the book has some issues here with the way they present these questions. So again, I'll make sure I take care of that. You can't just create a random point, z, and put it anywhere you want and have an isosceles triangle. That point has to be in the middle of those 2 points. Z has to be somewhere along, in this case, on the y-axis. I can't put z over here and say, oh, we've got an isosceles triangle. That's not true, because this would be a shorter distance than that. So I'll cover that, cover that issue up whenever the book brings it up. Maybe I should be writing textbooks. I don't know. But anyway, that is 4.9. I mean, it's really not that crazy of a chapter. I mean, this is, again, more coordinate proofs. So that's about as hard as it'll get. The rest of it is pretty straightforward if you understand your properties. So what you need to do, we have a quick lesson quiz. This should be a pretty simple one compared to some that we've done. You will see you have to deal with some fractions. Deal with it. Like I said, I say a lot, just deal with it, stop your whining, right? But again, go ahead and fill these out. You'll see there's 2 parts, so make sure you fill out all the way through number 6. Don't forget about it. And again, make sure you're answering the question. Like here, it says find A and each angle measure. Please find all the angle measures, please. Don't just stop at A. And then do your reflections, and I'll see you guys in class.